I forgot. Okay, so what I want to just convey here is basically uh, what is PySpark, right? So basically, PySpark is nothing but using your Spark API with a Python syntax, right? So you develop your application and you want to write a Python code and make use of a Spark API. Basically, that's called PySpark. Okay, so all the so a Spark Core API, which will have uh, the abstraction type called RDD. Okay, and so you can actually build your system using RDD. We'll go in detail what is RDD, other stuff. So you have other components also in Spark. So these APIs you can access through different programming language using a Java or Scala or Python or R. Okay, so if you use so you can use using Java, Scala. If you use Python with Spark API, they call it a Spark PySpark, and if you use Spark API in R programming, that's called Spark R. So that's how. So in this course, I am focusing on how to actually develop a Spark application using Python programming, which is a PySpark. So here I am not covering the Scala aspects.
So, Pari, when we talk about using Spark with Python, right? So,
Yeah.
as per the industry standards today, like, are the recruiters stringent on that? We need a guy with Scala, or how it is how it goes?
Yeah. So basically, so how it goes is it depends upon their project they want to develop, right? The resource they want to say. Example, I build a application, big data solution today, for think as a retail. I run a retail business. Okay, so I want to build some use case on my retail data set. Okay, so one thing is just finding insights, just kind of doing a ETL process and finding the reports, generating reports, and stuff like that, right? So then uh, you might need actually people who might need just bringing the data to the your centralized place. It's more of data warehouse related people needed, right? So they might be worked on different data warehousing tool like Informatica Power Center or Microsoft MS, the integration service or Talent. So when it comes to building the big data system for again the detailed process, then they might find with the people who knows very good about Spark SQL, right? Or Hive from the Hive component from the Hadoop system, right? Then you might not differentiation between a Scala, whether Scala programmer needed or a Python programmer needed, because end of the day, the internally you are going to use the Spark SQL. When it comes to the uh, any machine learning use cases, say you are not going to just do the simple analysis on your data, you're also going to build the predictive models, right, using different machine learning algorithms. That's where actually people will try to say that I need a person who worked on basically a Python oriented Spark or uh, the stuff like that. So uh, Spark with a R, I don't see actually, at least to my knowledge, I have not seen people asking for Spark R. It's more on whether PySpark or PySpark requirement or Spark with the Scala requirement. I at least see some of the polls in LinkedIn, probably you would also seen it. If you see the polls, most of the requirement, the highest requirement will be PySpark, then followed by Spark with Scala. People will have different opinion. At least to my view, this is the see I see it. So yes, so either they will ask you whether they will expect you either Spark with the Scala or Spark with the Python, which is a PySpark. So if you
Okay.
just go and check in your LinkedIn job description, they mention Spark. They'll definitely mention Spark. And then the skill when it comes to programming language, they'll say either Python or Scala. And some people they mention clearly Python or they need a Scala people. Yeah.
Okay. Got it. Yeah.
Yeah. Uh, uh, Anyone has any questions, so that we'll start with the introduction. So this session is more of introduction. I will cover the SDFS part. Then tomorrow we'll focus on installing the Hadoop and start with the MapReduce. I want to so SDFS is more of concepts and commands which you will be learning. But when it comes to MapReduce, probably you need to know the how the Hadoop framework you can install. Then you'll have more clarity. So what I will do is today I will cover SDFS in a eye level, and then we'll start tomorrow the Hadoop installation. Then MapReduce. Then we'll go live and further components. So if this meeting disconnects, please use the same link on join. Basically, there's a limit of 40 minutes. You can use the same link and you can rejoin it again. Right. So does anyone have question, or else I will start with it?
Just one thing, last thing, buddy, will there be hands-on on all the components that you shared, or like it would be like how it will go?
No, every component is going to have hands-on. There is no yes, there will be a concept explanation, then followed by the hands-on. Yeah, that's how it goes.
Okay.
Yeah,
Cool. Thank you.
yeah, no problem. So SDFS is more of use commands. More of SDFS is more of concepts, but I will include there also hands-on so that it's better understand. Okay, all right. We'll start with the Hadoop. Sorry, the okay. So just we'll before getting into the SDFS, we'll just understand what is big data. People might already know it. Uh, so just I'll give you just brief introduction, right? So so basically, big data generally refers to large or huge amount of data, right? So that is in layman term, right? So if you want to measure your big data in terms of the in terms of some units, so it ranges from basically the data units are ranges from bit to the megabytes, gigabytes, and so on, right? People call certain data as a big data if it is a thousands of gigabytes or in terabytes or petabytes. They generally call it as big data. So then you might see how this big data getting generated. So most people already might have faced it or maybe known it. So one specific platform where we see at least we can actually be in see in daily day-to-day activities, or we do which is social medias, right? Social media domain generates huge number of data because almost everybody uses social media nowadays. So just some of the data points I took from internet. So here they say in this is as per 2020 the statistics. So every 1 minute, okay, every 1 minute, YouTube actually uploads people in YouTube. The users upload 500 hours of video. The 500 hours of length videos in a YouTube in 1 minute. Okay, then think of the data, how much data is getting growing, right? Similarly, if you look at the Facebook, they actually do in a minute 150 thousands of messages being shared between users in a Facebook. And if you look at the LinkedIn, there is a 69 thousands of job posts being shared in the LinkedIn. So there are other Facebook, other social media generates a huge amount of data. Okay, just for your information, right? So if you go to other domains, technology, banking, we know like banking, how when you use each transaction, or if you use any banking, use everywhere if you generate data. So apart from that, there are so many smart devices which has come starting from your wristband and even now, even the home appliance like washing machine or even lights, everything is now become a smart devices which emits data in a in a in a second, in a seconds or milliseconds. So that's how the data is being big data being generated in the market. Now the question, okay, so before getting into how to process those big data, or which are the tool stack we use to process those big data, uh, there is no official definition for big data, but there are IBM actually like few years back. So when the big data was people have started about talking about big data. So IBM actually told there are three characteristics on which you can actually measure, or you can actually say this is a big data. One is with respect to volume, which already we talked about in general. Layman, when we talk, people talk, we talk like the huge data, which in terms of volume, we call it as big data. And we call the data which is getting generated in a very short span of time, right? So it is in millisecond, if it is in second. So that, and it generates huge amount of data in that particular duration or window. Then it is also called big data. And when it and the another characteristics is basically a variety. So you not only restrict it to the structured data or semi-structured data, you also have unstructured data like videos being uploaded to the YouTube, and you see the photos being uploaded in Twitter or Instagram, like social medias. And even we use images in medical healthcare industries and different domains. So these are all also referred as big data, like different data types, or maybe the data formats, in terms of variety of data. Okay, these are the three characteristics IBM says can be measured or can be conveyed as big data. So apart from this, there are other characteristics as well, which refers veracity. Veracity refers that noise and abnormality in your data. Okay, so people who worked on data analyst role, or kind of machine learning role, they know that. So when the data comes to their team, that data has to be a cleaned data. So means if you have the proper normalized, or not normalized, basically the uh, process data which has proper information, then only they can use it for the machine learning model building. So if your data is not proper, having so much noise, it's very difficult to build a machine learning model which will not perform a good prediction. So there will be a noise in your data. So if your noise is more on your data, that's also referred as big data. So this can be normalized using different techniques available, and you can also do some pre-processing and do stuff like that. So veracity is refers to the noise or abnormality in your data, and there is another characteristics called variability, which refers a constantly change in your data. Okay, so now these are the okay, big data is available, which getting generated from different areas. So how do you process them? Okay, so if you want to process the big data, there are different tool stacks available. Okay, now we are going to focus on Hadoop and Spark. So when the Hadoop was introduced, so they introduced with the two main components. One is the HDFS, Hadoop Distributed File System, and another is a distributed framework called MapReduce. Okay, now and this has been introduced. This has been based on master-slave architecture. So if you look at the traditional database architecture, so will be having very specialized or hardwares, which is the servers are made up of specialized hardware for building to actually install a database softwares or any web server, app server. Then we will store our data into that. Okay, so data will be sitting on that particular one server. This is the traditional database server architecture, earlier, not now. So whenever we want to increase the performance, or if you increase the storage capacity of your server, you just go and upgrade your server. You do the it's called horizontal vertical scaling. Like you just go and upgrade the same machine with more configuration. It's called vertical scaling. uh, so when Hadoop was introduced, it's more of master slave architecture. So you will have one node which act as a master node, which delegates your work to the slave nodes, or maybe the nodes which does the which actually stores your information in a multiple machines. So as a user, you see the global view of your data, but internally it stores small pieces and in a multiple nodes in your cluster. So and